Hey folks, welcome. In this lesson, we're going to talk about Elastic Load Balancer security. So in the DevOps doctrine, let's click on our ELB Security button. Okay, so there are several ways you can apply security, and of course, we can use security groups to apply security to our resources. But what we're specifically going to focus on in this lesson is talking about security between clients and our Elastic Load Balancer, and also security between the Elastic Load Balancer and our backend instances. Now, in the DevOps profession and certainly on the certification test, you may run into the term end-to-end security. This is what we're talking about. We can apply security between client and load balancer and still be unsecure between load balancer and our backend instances. So dealing with security on both ends makes the environment end-to-end secure, and that's what we want to talk about in this lesson. And the thing about end-to-end security is that, well, it could be a requirement, but it may even go a step further. It may be a compliance requirement. So certainly when we're taking a certification test, we don't usually have diagrams to look at unless we draw our own, which is a good policy if you have time. But in this situation, we're talking about two separate entities here. We're talking about this line of communication, client to load balancer, and this line, load balancer to the backend instances. We can encrypt this communication, but to be completely secure, we also need to encrypt this communication. So we have to set up our ELB listeners, which we will see here shortly in a hands-on walkthrough. So we need to configure the listeners for the front-end clients to connect to, and also for the back-end clients to connect to. This can be HTTP, and if we want to make this secure, it can be HTTPS. We can also use TCP, and again, to make it more secure, SSL. And typically for these communications are done on port 80 for HTTP as an example, and port 443 for HTTPS. Now, those are the common ports, but you're not restricted to just using those ports. To summarize, if we set up our listener on port 443 rather than port 80, so on port 443 we're using HTTPS, we are making this connection secure. But I'll reiterate, we could still set up this communication. We could set up our listener on port 80 using HTTP. And that is not secure, and therefore our end-to-end would not be completely secure. Now, HTTP/HTTPS and TCP/SSL have their differences. HTTP and HTTPS are on layer 7. While they can analyze headers from requests, you need to use X forwarded 4 header to get the client IP address. And one advantage with HTTPS is you can enable sticky sessions. Now, TCP and SSL just being the secure version for TCP, is on layer 4, and of course that's the transport layer. Now, the client IP address is not easily obtained, but you can use proxy protocol to get the client IP address. Now, the one difference is sticky sessions cannot be enabled. And that's a key point. With a sticky session, the client can be quote-unquote stuck to a back-end instance where they will not lose their session. So it is an advantage to have sticky sessions. Being at layer 4, the TCP is not able to receive cookies, which are at layer 7. Now, if you decide to go secure, and on this front end you decide to use HTTPS or SSL, you need to deploy an X509 SSL certificate and also specify security policy. And this enables the load balancer to decrypt requests from the client before forwarding those requests on. And this is called SSL termination. Now, if we do not want the load balancer to handle that encryption, we can set up the backend clients to do just that. So we would deploy certificates on the backend clients as well as the load balancer. Another thing we can do is use backend server authentication to make sure that instances only accept encrypted communications. All right, so let's talk a little bit about configuring backend authentication. And let's go into our key concepts. And most of this is review actually. Can configure an ELB to have secure communications with front-end clients and back-end instances. ELB listeners check for connection requests. Options are HTTP or HTTPS on layer 7, TCP or SSL on layer 4, and typically you're using ports 80 or port 43. Okay, so configuring back-end authentication. You first need to create a public key policy. And this public key policy is used to create a backend instance authentication. Then we can set this backend instance authentication policy with the instance port and the protocol, either HTTPS or SSL. And that's a very key point. Once that is configured, the ELB only communicates with an instance if it has a matching public key. Very crucial point. So, authentication policies can have multiple public key policies, and the Elastic Load Balancer cycles through and tests each public key policy until it finds a match. All right, let's go back to our diagram, and we've pretty much covered the concepts here. So let's complete the lesson with a hands-on walkthrough. So we first want to create a load balancer. And of course, let's click Create Load Balancer. And we want a classic load balancer. So let's click Create. All right, and we're going to want the classic load balancer. Now, of course, there's the application load balancer and the network load balancer. And certainly really cool technologies that DevOps engineers should know well. So I would encourage you to certainly check those out and get up to speed if you are not already. But the classic load balancer is still featured on the DevOps Pro certification course. So we're going to select that one. Let's click Create. And let's just call it ELB for Security Lesson. The default VPC is fine. All right, now here we go. So this corresponds to our diagram. So on the front end, right now would be HTTP port 80 and the back end HTTP port 80. So if we accepted this right now, we would have no encryption whatsoever from end to end. Well, let's change that. So let's deal with our front end first. And we'll use HTTPS, and it spells it out. Secure HTTP. Note, it fills in 443 for us. And of course, that's our default secure port. And if we left it as is, we would not have secure communication between our ELB and our backend instances. And in some cases, that's okay. But our focus has been on this end-to-end security. So let's change that. And again, notice that it goes right to 443 when we select the secure HTTP. All right, so this is what we want. Let's move forward. And the default security group for this situation is fine. Let's move forward again. Okay, now here's where it gets interesting. Now we're going to define our certificate. All right, so our options are choose a certificate from ACM, which is AWS Certificate Manager, and that is recommended. So let me click on that. And we get into a bit of configuration. We can select a cipher, protocols. Now, the problem is that I don't have any certificates in ACM. You see this drop down is not populated. So let's check out option 2, choose a certificate from IAM. And you'll see I can't even select that. And that is because I do not have a certificate in IAM. So that leaves option 3, upload a certificate to IAM. So let me select that, and I'll just call this test cert. So we need to provide a private key. Now note, PEM encoded. Boy, that sounds familiar. What's that about? Well, remember, our key pairs are in PEM format. They could be PPK, but generally they're PEM. So if our key is not in PEM format, we need to convert it to PEM. All right, we can also plug in a certificate body. Certificate chain is optional, so we'll leave that. And this gets us back to this certificate cipher. Okay, so we have a predefined security policy. And if we just open up the drop down, have some other options, but unless you really know what you're doing, probably just leave that as is. And if we are really security savvy, we can go ahead and create our own. But I'm going to stick with the predefined policy, and we get to the backend certificate. Remember, we talked about backend authentication. So proceed without backend authentication or enable backend authentication. Let's go ahead and take a look. So we can give it a name. Now with this one, we need to strip out those leading and trailing lines. Now remember, we can have multiple public keys. Our ELB will cycle through those until it finds the correct one. So we can add more. Okay, and that would complete our configuration of security settings. We could then go on to configure health check, add EC2 instances, register EC2 instances to our load balancer, add tags, review, and then create. Now, I just wanted to show the walkthrough on this. I do not have a valid certificate, so I'm not going to complete this. But if you have a valid certificate, that's all there is to this. So with that, we have completed talking about Elastic Load Balancer security and a walkthrough on configuring our security. So go ahead and complete this lesson, and let's move on to the next.